Hi everyone. So in this video, we are going to learn cycloid. Okay. So cycloid means a cycloid is a curve generated by a fixed point on the circumference of a circle. So which rolls without slipping along a straight line. So it is a curve which rolls a horizontal surface for one complete revolution without slipping. Okay, so the question will be like this. Construct cycloid, a circular plane 50 mm diameter, which rolls on horizontal surface for one complete revolution. So assume that point P at bottom of the circular plane. So this is the question. So in this question, we can observe the diameter of the circle. So the diameter of the circle is given, that is 50 mm. So first of all, we will start our construction of the cycloid with the circular command. So the circle diameter is given, that is 50 mm. Then after we need to draw one horizontal surface, that is the diameter, dimension of horizontal surface is 2 pi r. So along that we need to place a point and track that point. We will get a cycloidal curve. So let we start with circle command. Circle and diameter is given in our question. Take center diameter option and draw one circle. Okay. Then enter diameter 50. 50 enter. Okay. So next, so this circle we need to divide n number of equal parts. So the n number of equal parts may be 8 or 6 or 12. That is your choice. So I am going to divide this circle into 8 number of equal parts. Okay. For that, I am drawing a line from the center of the circle to any quadrant. Okay. Then select this line, go to polar array and click center of the circle. By default, it is divided by 6 items. I will change it 8. Okay. Next. So we need to find circumference of the circle. We need to find circumference of the circle. For that, we have a calculator here. In utilities, we have a calculator option. So for finding circumference, we have a formula, that is 2 pi r or pi into d. Okay, pi into d means diameter of the circle. So diameter of the circle is 50 mm. So pi into d equal to 157.07. So roughly we can take as 157 as the circumference of the circle. So take the line from this bottom point, draw one horizontal line. The distance is 157. Okay, this is generating line. This circle is, we can call a generating circle. Okay, so in this line also we have to divide n number of equal parts. So how many numbers does the circle divided already? So same number of parts we have to divide this line also. So for that we have a command, that is divide. Using divide and select the object and enter the number of segments 8. Enter. Okay. So this line is also divided by 8 number of equal parts. So then, so from this end point, we need to draw 50 mm line and join to this circle. Join to this circle. So a rectangle box will be formed like this. So then after each and every segment, we have to join up to this line. Okay. Then after we need to give the notation. Okay, by using single line text, we need to give the notations. So here point P. Okay, go to single line text where you want. Here click on and enter text height and rotation 0, enter. So this is the point P, and first point 1, and second point 2, and third point 3. Like that we have to give up to 8 points. Sorry, this is fine. So point P and point 8 both are at similar location, same location. Next, in similar manner, you have to give this horizontal line also. The notation we have to give this horizontal line also. The first point is this one. This is 1 dash, and this is 2 dash. This is 3 dash and 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. Okay, clear. So next we need to draw perpendicular lines to this location of the center line. This line is we can call locations of this center line. Okay, locus of center lines, locus of centers. So here we have a one center point, that is C. So this is the center of the circle, this C. So this line we can call locus of centers, locus of centers. So draw a perpendicular line from 1 to this locus of center line. Okay, so I'm copying this line. This is step 2, 3, 4, 5, 6, 7, and 8 also. Okay, so give the notation. This is C1. Okay, this is C2, C3, C4, C5, C6, C7, and finally C8. Okay, so now, so we need to trace this point P, okay, in these horizontal lines. So for that we need to take the circle. Initially, same what are the circles we have drawn previously, same diameter we have to draw the circle from center one. Okay, from center one, it is C1. We need to draw same diameter circle, that is 15. Okay, so this circle and the first line, okay, line 1, and that means 7 1 line. This line will meet here. This is the point P1. Okay, this is the first point here. Okay, this is the first point. So, and if you want to find the second point, we need to move this circle into point center 2. You need to move this circle from C1 to C2. Okay, so this circle will cut the second line, that means locus of center line here, that is the point 2. In similar manner, we have to take the points, all the eight centers along this line. We have to mark the points up to 8 points, and by joining these points, we will get a cycloidal curve. Okay, similar procedure we have to follow up to 8 points. So next, change the center 2 to 3. So this circle and this third line will intersect here. So this is the point 3. And next, change the center 3 to 4. So here we have a intersection point. So make a point here and then change the center C5. So here we have a 5 3 line. Okay, 3 already we have denoted here, and we need to denote a point, that is fifth point. This is the point V5, and next move to the circle from C5 to C6. So this is the sixth line. So in this sixth line, we have to make a point here. Sorry. Okay, this is the point 6, and then move to the circle 6 to C7. So then here we have a seventh line, 7 1 line. So here we have to make a point. Okay. Then eighth point is always here is the final point, 8 points. Okay, this is the circle we don't need, so we can erase it. So give the naming for each and every point. This is point P1, this is the point P2, point P3, point P4, point P5. 6 7 then 8. Okay, we get all 8 points. So by joining these points, we will get cycloidal curve. So for joining these curves, we will use the spline command. Okay, with the help of spline command, we will join these points. Okay, in draw toolbar, we have a first option, that is spline fit. Take this command, and from the point P, we need to join first point and second point and third point, 4, 5, 6, 7, 8, and the tangency, and enter. Okay, so give the line weight if it is work. Okay, so this is the cycloidal curve. Clear? So next, in some cases they will ask draw the tangent and normal also. So for that, we need to draw the tangent and normal in sometimes. So for that, we need to place the point anywhere on this curve. Anywhere on this curve, we have to place the point. So I am placing the point here. Okay, I will change the color for easy identification. So, so this is the point P, the point P. So in this point, I am going to draw tangent and normal. Okay, at this point, I am going to draw tangent and normal. So first of all, for drawing this tangent and normal, we will take the circle. Okay, we will take the circle and diameter is 50 mm. Diameter is 50 mm. Center is P and diameter is 50 mm. So this circle and locus of center line. This circle and locus of center line will intersect here. Will intersect here. So here also we will make a point. Okay. So we don't need this circle. Erase it. So from this point to the generating line. Okay. This generating line, we need to draw a perpendicular line. Perpendicular line. So then after from this point to this P. From this point to this P, draw one line. This is a normal line. This is a normal line. Okay, this is a normal line. So, for example, this point we can denote it by we can denote it by O. We can denote it by O, and this is the normal. So here we can denote it by N. N. Okay. So copy this line, and paste it somewhere. Sorry, Control C and Control V. Copy this line and paste it somewhere and then rotate 90 degrees. Select base point and enter 90. Okay. So move this line to point P. Okay, this is the tangent line. This is tangent. Tangent. Okay. So give the line weight if it is works. So this is the procedure for drawing this cycloidal curve. So first of all, I will explain once again. First of all, take the circle with the diameter 50 mm. Okay. So thereafter, divide the circle into n number of equal parts, that is 8 number of equal parts. Okay. By using polar array command, and then draw one perpendicular draw one horizontal line. The line distance is pi into d or 2 pi r. So that is 157 line. So after drawing this line, how many parts we are already divided this circle? Same number of parts we have to divide this line also. So after dividing this line, we need to draw perpendicular lines to locus of the centers line. This is the locus of the center line. So up to this line, we have to draw a perpendicular lines. So these are the centers of the circle C1, C2, C3, C4, C5, C6, C7, C8. Up to C8, we have to draw 8 lines. Okay. So then after each and every part, we have to extend up to this line, this end of this line. Okay. And join, form a rectangular box. Next, we need to mark the points. Okay. We need to trace the point P. Okay, for that we need to take the circle C1 as the center and the diameter is 50. So that circle and this line, 7 1 line will meet here. That is the point 1. And same circle we are using to move at point C2, center C2, and we will get point 2 and move to same circle C3, then get point P3. Like that, we get point 4, 5, 6, 7, 8. Okay. So this is the procedure of cycloid. Okay. Okay. So, okay. Thank you.